Welcome back everybody to another video lecture from Miss Semino. This is the second video in the acid bases series for my honors chemistry classes. This video is focusing on calculating pH and pOH. So more specific objectives here are to describe how the concentration of hydrogen ions and hydroxide ions are related in an aqueous solution. We also need to classify a solution as neutral, acidic, or basic given the hydrogen ion or hydroxide ion concentrations. And we're going to be able to do that using the math. So we're going to be converting hydrogen ion concentrations into pH values and hydroxide ion concentrations into pOH values. And we also need to describe the purpose of acid-base indicators. So on this slide, we're going to go ahead and talk about water, how it ionizes, and this thing called the Kw value. We've seen this K value a couple of different times. Remember, it can stand for an equilibrium constant. We're also going to be using it as a ion product constant here. So first off, water ionizes or falls apart into hydrogen and hydroxide ions. This is called self-ionization of water. This occurs only to a very small extent. Sorry about that. I'm sure you guys heard the phone ringing in the background, birds chirping outside. I guess this is going to be a noisy video. So as I was mentioning, the water self-ionizes or comes apart very infrequently, and so we can see that we are going to have this kind of concentration of these ions in a solution. And so since it's to the -7, you can see that that's actually like not very many of those ions in water. And so here it says, since they are equal, meaning these concentrations of our hydrogen and hydroxide ions, a neutral solution is the result. So here's this Kw value, and we saw this in the POGL when we were working on it, that calculating pH POGL is if we have our concentration of hydrogen ions times our concentration of hydroxide ions, that's always going to equal this value of 1 times 10 to the -4th molarity here. And so that means if you know this value, this is going to stay the same, it's going to be a constant, you'll be able to calculate this value, or vice versa. The Kw is called the ion product constant for water. And later in this chapter, we're going to see something called a Ka value and a Kb value. So just kind of get used to seeing all these Ks all the time. So let's talk a little bit more about these concentrations of hydrogen ions and what they mean, and this ion product constant. So just to review, water can ionize into our hydrogen ion and our hydroxide ion. I mentioned on the last slide that Kw is a constant, meaning that this value is not going to change. So here's our little formula. You're just going to need to memorize this. Our concentration of hydrogen ions times our concentration of hydroxide ions is always going to equal this value. So as I mentioned, you can calculate your hydrogen ion. So if your hydrogen ion is greater than 10 to the -7th, then your hydroxide ions will be less than 10 to the -7th. And so if you have a lot of hydrogen ions, you know your solution is going to be acidic. On the other hand, if your hydrogen ion concentrations are less than 10 to the -7th, well, you know then your hydroxide ion concentration is going to be greater than that, and so then your solution will be basic. So we kind of just said that same thing here. So if this is bigger than 7, it's acidic. If this is bigger or smaller than 7, then we know it's going to be a basic solution. And just as a reminder also, basic solutions are also called alkaline. I don't like to use that term alkaline too much though, because sometimes kids get alkaline and acidic mixed up, but alkaline, it means basic. So on this slide here, the pH concept, remember the pH scale goes from 0 to 14. There's some exceptions we'll talk about in AP Chem, but that's just the general rule you guys need to know for now. pH stands for this in French. I'm not even going to take a guess at that one, but also known as the hydrogen power or the potential of hydrogen. The definition or the formula for calculating pH, it's going to be the negative log of the hydrogen ion concentration. So in a neutral pH, remember that our negative log is going to have this value, which is going to equal 7. So if we were to plug this into our calculator, negative log 1 times 10 to the -7th, we would come out with a value of 7, and so of course our pH is equal to 7 there. So we've seen the pH scale before. Here's just some more examples of some different types of acids and bases on here. So remember, as you're moving down the pH scale or closer to 0, you're increasing in acidity, and as you move towards the higher numbers, you're increasing in alkalinity or basicity. So 2 slides ago we talked about how to calculate pH, so now we're going to talk about how to calculate pOH, and really you're going to see it's not any different than calculating the pH. So our pOH is going to equal the negative log of now our hydroxide ion concentrations, and so that makes sense. Before it was just pH here and it was just an H here, so now it's pOH, so here's our OH. So again, we have this formula that we can use. That it's just something that you guys are going to need to memorize. Also remember this relationship between pH and pOH. If you take your value of your pH plus the value of your pOH, it's going to equal 14 every single time. So thus, a solution with a pOH of less than 7 is basic, with a pOH greater than 7 is acidic. And you're like, whoa, Miss Semino, you just said this I think you said this backwards, but notice that we're talking about pOH. So if our pOH is less than 7, then we are not going to be acidic, it's in fact going to be basic. So if we just kind of plug these numbers in here, so let's say my pOH was let's see, less than 7, this is going to be 3. That would mean that, and we're going 14, and so we're trying to find this value over here, so our X of course is going to equal 11, and so anything with a pH of 11 is going to be basic. And so then the reverse is true. With a pOH greater than 7, you're going to have an acidic solution. It's not as used as often as pH, but you'll still see it used occasionally. So for my AP bound kids, you need to know this pH in significant figures. It's not something that I'm going to harp on in honors chemistry. Just know that it's a little bit different when we're talking sig figs. We're really looking at sig figs to the right of the decimal. So talking about why we measure pH and how we measure pH, well, we need to measure it for everyday solutions, things like swimming pools, soil conditions for plants, medical diagnosis, soaps, shampoos. So we want to know the pH of these things. And sometimes we can use indicators, and others we might need a pH meter. And so maybe if you have a fish tank, you might have done like these little measurements to just measure, like if you've had some fish die, you're like, oh, I need to test my water, so pH is one of the things that they'll test right away. So when we talk about indicators, this is like those little test strips that we were using in class, but just like we used those electric temperature probes earlier this year, there's also these pH probes or pH meters that you can use. Here is just some general rules for using pH strips. We've already gone over this with our lab. Here is a list of indicators that might be used. The one that we're particularly going to be using in class is phenolphthalein down here. Later for AP Chem, you're going to need to know about methyl red, methyl orange, and then bromomethyl blue, BTB, right here in the middle. But for right now, we're just worrying about this pink colored phenolphthalein. So these acid-base indicators that we were using in class were pretty good, but they weren't giving us very specific pHs. Also, there are some limitations, so if you're not at the right temperature, or if your solution already has a color associated with it, using these paper indicators is difficult. So if those little strips of paper aren't working so well, what else can you use? Well, you can use these things called pH meters. They can be really large, but then others are really small that would probably fit in your pocket. We only have a couple on campus, so we might use them, or we might not. We may or may not use them this year in class. So overall, you guys, on this video, I just wanted to review quickly what kW was, what the value and the formula for that was. Remember that your kW is equal to 1 times 10 to the negative 14th, and you're getting that value by taking your hydrogen ion concentrations times your hydroxide concentrations. Also, that pH can be measured by taking the negative log of your hydrogen ion concentrations, and we can also measure something else called your pOH value, and that's by taking the negative log of your hydroxide or your OH concentrations. And then finally, your values of pH plus pOH are always going to equal the value 14. As always, remember to write down questions that you have and ask me in class. Thanks.